In this video, we will be talking about how to determine if a number is a prime number or not. All right, and I expect you folks go ahead and watch this video from the Khan Academy on how to determine a number is a prime number or not. Okay, so once you've done that, it's a simple algorithm. There's no rocket science in that. And so the way we are going to convert that algorithm or the technique into an algorithm is I given you here the flow chart. All right, the flow chart, basically this is what it says. We'll take a number given by the user. All right, given by the user, he enters a number, and to check if the number is a prime number or not. Okay, number is a variable, very simple. And so we're going to start from 2 all the way up to that number. So let's call that as x. Okay, this is x variable, and we are going to use another variable called a Boolean variable called not a prime, a prime. All right, so let's type it there itself, a prime. So we're going to assume that it is true to start with. Okay, and so this variable starts from 2 to 3, right? The way it goes all the way up to the one number less than the number. So it's a loop, right? So and then we'll check if we go here. So we're going to assume a prime equal to true. That's what I said here. It's true, and it's going to start from 2, the x value, and the number, let's say he enters 17, right? He enters 17. And let's put a Excel sheet. Let's take an Excel sheet here. That's way is easier to, it's on the side. Okay, let me put it here. So this is a number. Let's take 17, all right? And this is a x number, and this is the not a prime, all right? A prime, and we said we're going to set it to true, all right? Set it to true. So let's say 17, and we said we're going to start from 2, we're going to start 3, we're going to start 4, 5, 6. I can just drag it up to 16, right? 16. And so we're going to start from x2, and this is the number that user entered, 17, and we're going to check if let me insert a mod operation, right? Mod operation. And is 17 a mod 2? We're going to check if it's equal to 0, right? So that's what this algorithm talks about. And we're going to start from 2, 3, 4. That's while loop will take care of that. And inside, we're going to check if that number mod 2 is equal to 0 or not. If the mod is 0, that means the remainder is 0. What does it mean the remainder 0 means? That means, let's say, for example, 18 mod 3, it is 0, right? That means 18 is 3 divides 18 equally. So that is not a prime number, not a prime, right? So we are going to check if this number ever divides this, right? That's what we are checking here. If the number ever divides and the mod is 0, that means we are going to change that to false. Period, right? Going to change it to false, and we continue, and the end, obviously the loop will terminate, and then we're going to check here, did we ever change the Boolean variable to true or is it false, right? If it remained true, that means it is a prime number. Our assumption is right. If it ever changed to false, that means not true, then it's not a prime number, right? So here Excel sheet, and so its mod 2 is not 0, so it's true, right? It's true. We're going to change it true. So similarly, we are going to check 17 mod 3, and obviously the remainder 17 mod 3 is what is the value, is the remainder is 2. So obviously that's so it's still, so far this is prime number so far. So we're going to continue checking all that mod. You will realize it never changes to false. It always remains true, because there's, if you go back to my here, 17 mod 2, 17 mod 3, 17 mod 4, 17 mod 5, it go all the way, it never ever 0. See that? It's never ever 0. So 17 is a prime number. Alright, 17 remains a prime number. Let's take another number, 9, right? Here is 9. Let's take another number, 9. So 9. So when you take 9, right, we're going to start, of course, let's see if I can delete all statements. Okay, so 9 mod 2, the remainder is 1, so we are going to make it so far true, right? So far. And 9 mod 3, what is that? The remainder is 0. So we are going to change to false. You see that the algorithm says change it to false. If it ever equals 0, change it to false. So we are going to change that to false, and that's it. It doesn't matter what the remaining numbers are. I can just stop it right there. But in this algorithm, we're not stopping. We are continuing, right? Despite we know that it's not a prime number, right? We're continuing. So we're going to make improvements to that. That's fine right now. But this is the algorithm to test if a number is a prime number or not. So here, if you see here, we have initialized the variables, the 3 variables, a prime, a number, and x, and we are continuously checking a while loop. You see that while loop, and the algorithm is very identical to this flow chart, where increasing x equal to next number, right? Next number. And once the loop is done, in this case here the loop is done here, we are going back and checking what happened to that boolean. Does it remain true or it changed to false? That's what, it remained true or it changed to false. So in this case, for example, we could just stop right there. So how do we stop is the question. How do we stop? There is a exit statement. There is an exit statement, exit while loop. That means whenever you feel that the iteration is no need to be there is no need for the while loop to continue, if you put this statement there, it'll exit the while loop. For example, your while loop is here, right? Keep looping all the time, is looping. This is a while loop, for example. At somewhere you realized, I don't want to continue this while loop. So what you do is just say exit while. If you do it, it will discontinue the loop, exit out of the loop, get out. It won't continue further. So I have modified the algorithm for you here, and all you got to do, if you go back, I'll just go back here. Go back here, and all I did is change that, put a exit while right there, because we know the prime number is false. That means it's not a prime number anymore. Why continue further? So that's why exit while. See here, right here we check exit false, I stop. I want to stop. I don't want to continue all these things. This is unnecessary, right? It's like going to, once you determine that you left your wallet in your home, what is the point of shopping, right? There's no point in shopping. So you stop, you go back, right? Same thing here. You determine if a prime number is not a prime number anymore, so we don't want to continue the rest of the numbers, we could stop. And also there is, to make it efficient, I divide by 2. This is immaterial at this time, but you can take it as a homework why I do that, right? But anyway, so go ahead and review the code and the flow chart, right? It is a lot of while loops are done like this. There is always a flag, a looping variable, and you check inside. That's the whole concept about looping is you loop and make sure you terminate for some conditions, right? Thank you.